aside from maybe rounding differently, are you guys getting the same thing per second derivative?
V is supposed to be a variable for velocity, is that what it is?
I'm sorry, Josh,
Is V's velocity, is that what it is?
V is velocity, yes. Okay, then the partial derivative of W with respect to V and T again, it doesn't matter who went first, because this is a continuous differentiable function. So I don't know if, in this case, one is easier than the other. If I take that one and find the derivative with respect to V, I'm going to get 0.3965 times 0.16 V to the negative 0.84. If I take this one and take the derivative with respect to T, I'm going to get 0.06344 V to the negative 0.84, and I suspect if you multiply those numbers together, that's where I got that number in the first place. Okay, so I think in this case it didn't really matter. It was easy enough either way. Okay, so this is measuring degrees Celsius of wind chill per degree Celsius of real temperature per degree Celsius of real temperature. So it's a measure of how the rate of change of wind chill is changing as real temperature changes. So it's saying it's not. The rate of change of the wind chill stays the same no matter what temperature you're at. It's linear in terms of the temperature. So because it's zero, it means it's, since this equals zero, it means there's no change to the rate of change. It also means there's no concavity in that direction. This gives us degree Celsius of wind chill per kilometer per hour, per kilometer per hour. So it's how the rate of change of wind chill per wind speed is changing with respect to the wind speed. I know we were supposed to plug in the negative 5 to 10, so we can do that in a minute. Yes, Annie?
Okay, so if you get zero and you're taking the second derivative, does that mean that you're like also, like is that like a crucial point and like you're at like a max or a minimum or something?
You know what, that is a good point. Yeah, there could be an inflection point there. It could be, yeah, it could, you could have an inflection point there, which means that you've reached in general, if you get zero, there could be an inflection point, which means you've reached a maximum slope or minimum slope. In this case, because it's zero all the time, we didn't plug a specific number in to get zero. Instead, the second derivative is zero for all values. Because it's zero for all values, it means that it's linear, it's straight in the direction of t. So in terms of our graph, if we look in the direction of t, it's linear in the direction of t. Like there's no concavity. But you are, but that was a good question. You are correct, that if, in general, if